Hi everyone, in this one we're continuing with key area 2.6, the structure and function of the heart, by looking at the cardiac output calculations. So the cardiac output calculation formula is the heart rate multiplied by the stroke volume. So the heart rate, how often the heart contracts, times the stroke volume, the volume of blood in each ventricle, and that will give you the total volume of blood pumped through each ventricle per minute. Remember that blood output is happening from the pulmonary side and the aortic side simultaneously. So, not just at the same time, but also in equal volumes. So, the same volume of blood leaving the heart via the aorta to go to all the different body tissues, and the same volume of blood going through the pulmonary artery, just going to the lungs alone. So, this ensures the heart always has a supply of oxygenated blood ready and waiting to go. So let's just practice some of these calculations. Pause the video and calculate your answer. So we can see we've got a graph question, so you should already know what I'm about to say. Start by just familiarising yourself with the graph, what it shows, its key. So we've got the work level in units, we've got the stroke volume in centimetres cubed on this side, the values on this side, and the heart rate in beats per minute, the values on this side here. Just a little note, centimetres cubed is the same as millilitres, so the numbers are the same. We've got the solid line with the crosses for our stroke volume, and the dotted line with the circles is the heart rate. Okay. The question, cardiac output is the volume of blood leaving the heart in 1 minute, and it's calculated using the formula heart rate multiplied by stroke volume. And you need to calculate the cyclist cardiac output when his work level is 6 units. Note as well that the unit you're asked for is centimetres cubed per minute, so there'll be no conversion required in this version of calculation. So do always check the unit you're asked for. Okay. So we know we need to get the heart rate and the stroke volume from the graph. So 6 units. So solid line, the crosses, that's stroke volume. So read from this side, so 140. And let's find heart rate. Read from this side, it's also 140. So we know from the formula we multiply those together. We don't need to convert it, we just need to state it in centimetres cubed. So 140 times 140 for 19,600. Here is another one for you to try. Pause the video and hit play when you want to reveal the answer. Here we go, we've got our graph. Again, we've got rate of oxygen uptake, litres per minute along the bottom. We've got our heart rate, beats per minute, values this side. Stroke volume, centimetres cubed on this other side. Dotted line with the dots is the heart rate, and the solid line with the crosses is the stroke volume. This time we've not been given the formula, we need to know that, and our unit is litres per minute, so a little bit different from the previous one. But otherwise, we still need to pull our values from our graph. So calculate the cardiac output when the rate of oxygen uptake was 2.4 litres per minute. Okay. So 2.4, let's go up. So the dotted line is our heart rate. So we need to read this from this side. So the heart rate's 120 up to the stroke volume, which is 156. The boxes are going up by a value of 2. So 120 multiplied by 156 But remember, we need it in litres, so you need to divide that answer by 1000 for a total of 18.72 litres. So hopefully this has helped, and any questions you have, do just let me know.